Now, in this video, I have a 6-volt peak-to-peak triangular waveform on my input. My frequency is 20 kilohertz. I have a 10 millihenry inductor in series with a 200 ohm resistor. My output, V out, my output will be sinusoidal, and I will be finding my V peak positive, my V peak negative, my maximum current, and my RMS current. Okay, now, the first thing I will do is I will find my L over R time constant. For 10 millihenries over 200 ohms. And that gives me 50 microseconds. Now I will be finding my period T. And T equals 1 over my frequency of 20 kilohertz. And that equals that equals 50 microseconds. Now I will take 1/4 of my period. That equals 50 microseconds over 4. That equals 12.5 microseconds. Now I will find my peak voltage. V peak equals 3 volts. The 3 volts is 1/2 my 6-volt peak to peak times 12.5 microseconds squared over 2 times 50 microseconds times 12.5 microseconds. Now, it's important that I make that distinction between this 50 microseconds and this one, because I'm not talking about this one, I'm talking about this one. Equals and this gives me 375 millivolts, or 0.375 volts. So my peak 0.375 volts, and that's my positive peak. And since my sinusoidal is even around 0 volts, my bottom peak is a minus 0.375 volts. Now, my max current. Since my voltage is being taken across my 200 ohm resistor, the calculation is really very simple. I max equals 0.375 volts over 200 ohms. And that gives me 1.87 milliamps. Now my RMS value, IRMS equals 1.87 milliamps over the square root of 2. And that gives me 1.32 milliamps. And this brings me to the end of the video. Subscribe, like, and share. Subscribe, like, and share. Thanks for your attention.